All right, for this last set, these integrals, there's quite a few of these 3, 6, 9, 12, 13. I'm not going to do them all. There's some that are very similar. So, okay, first one, number 24. Number 24, number 24. Okay, we're going to do u substitution for this. So u is going to be equal to x cubed. Du is equal to 3x squared dx. Bring the 3 out in front. Whoops. And I'm left with x squared dx, which is x squared dx. So now to write everything in terms of u, there's a 1. Mother! Alright, hopefully I'm back. I didn't curse. Alright. 1/3 2 to the u du. Alright, so again, the rule for this is going to be u prime over the ln of a times u. So 1/3 u prime is going to be a 3x squared ln of 2 times u, which is x cubed. And these 3's cancel out, so the integral of this should be x squared over the ln of 2 x cubed plus c. Yeah, that's not right. Mess that rule up. Hopefully I can edit that out, but if not, oh well. So integral rule. I was doing the derivative rule. The integral rule should be 1 over the ln of a times a to the u. So 1/3 times a to the u, which is going to be 2x cubed over the ln of a, which is 2. So that simplifies to 2x cubed and 3 ln of 2 plus c. Okay. All right, use substitution for a definite interval, so u is going to be equal to, excuse me, negative sine theta. So the derivative of sine is cosine, so it's going to give me a negative cosine theta times d theta. And that's just going to give me a negative du equals negative cosine theta d theta. So cosine theta d theta, whoops, positive there. So bring out a negative, integral from 0 to pi over 6. It's going to be 4u du. Alright, so the integral of this is going to be negative. It's going to be an a to the u, so 4 over negative, or to the negative sine theta over the ln of a, which is 4, and evaluate that from 0 to pi over 6. Alright, so f of b minus f of a, substituting pi over 6, that's going to give me a negative 4 to the negative sine of pi over 6. Let's do this whole thing. Over the ln of 4, minus, that's going to be a 4 negative sine of 0, it's a 0, not a theta, over ln of 4. I'll actually come up here and finish this. So that is going to be a negative 4. The sine of 30 degrees is 1/2, and that's going to be a negative. And then over the ln of 4, half. And 0 is going to give me the sign of 0 is 0, so 4 to the 0 is going to be 1, and that is going to be negative. Of the ln of 4. Then I'll just do a little simplification. So a negative 1 over, that'd be the square root of 4, so 2 ln of 4 minus 1 over ln of 4. And if I got a common denominator, which would be 2 ln of 4, or the ln of 16, so that would be a negative 1 minus a 2, so negative 3 over the ln of 16 would be our final answer. 26 I'm not going to do. 26 is just going to be an a to the u over the ln of a plus c. Again, 27, 28, those are both similar. U substitution. I'll do 27. It's a little bit more complex. This is just going to be an e to the u. So u is going to be equal to a 4x cubed plus 1 du equals 12x squared dx, and I'll factor out or divide out the 12. Those mean x squared dx, so x squared dx. So I'm going to get a 1/12 integrate 6 to the u du. So it's going to be 1/12 times a to the u, so 6 to the 4x cubed plus 1 over the ln of a. And that's pretty much it. You can write that as one fraction and be done with that. I just want to make sure my answer's right for that one. Yeah, plus c. All right, 29. I'll skip over to 29. The easiest way to deal with 29 is to rewrite each one of the terms in the numerator over e to the x. So if I do that, I'm going to get a e to the 2x, because I'm subtracting exponents, plus a 1 plus a 2e to the negative x dx. And then I should just be able to integrate each one of those parts separately. So I'm going to do e to the 2x dx plus 1 dx plus the integral of 2e to the negative x dx. All right, so the u substitution for this part is u is equal to 2x, du is equal to 2 dx. So there's going to be a half out in front. So there's going to be a 1/2 integrate e to the u du plus the integral of 1 is just going to be an x, and I'll take care of this u du versus the x. And then u substitution for this is going to be e to the negative, e to the negative x du is going to be equal to negative mistake. U is going to be equal to negative x, therefore du is negative 1 dx. So I can take out the 2 out in front, and now this new integral is going to be a negative 2, because I'll bring out the 2 and the negative, integrate e to the u du. And the first and the last one end up being the same thing, so this is going to be a 1/2 e to the u plus x, we already integrated the middle term, and then minus 2e to the u, and then a plus c. And that's that integral. All right, let's keep going here. 30, kind of the same idea over again. 31, you're just going to make u equal to x cubed plus x. Du is going to be 3x squared plus 1. If you notice in the numerator, we can factor out a 2, so that's going to match up. So I'm going to integrate factor out a 3, I'll put it out in front, and that's going to leave me with, factor out a 2, and that's going to leave me with a 3x squared plus 1 over x cubed plus x, a dx, and now it's going to be 2, and it's going to be 1 over u du. And that is going to leave me with 2 ln absolute value of u, which is x cubed plus x, and then plus c. And if you bring the 2 as an exponent, it's going to be ln of x cubed plus x squared plus c. Alright, coming down the home stretch here. 32. I will do 32. So for 32, u is going to be equal to x squared. Du is equal to 2x dx. Take out the 2. X dx. Rewrite our integral in terms of u. So there's a 1/2. The x dx is my du. And I'm going to have the cotangent of u. And this is, I think, our first trig one that we've done in a while. So 1/2. The integral of cotangent u is ln absolute value of the sine of u, which in this case is x squared plus c. And it's positive, and that is your final answer. Go back and make sure you review your integral rules for all the trig functions that we've done. 35. Let me see 35. Move it over a little bit. We'll see which ones of these ones I want to do. 33. 33, yeah, I'll do 33. 34, I will skip, and I will do 35. All right, 33. So u is equal to x minus 4. du is going to equal 1 dx. Now the issue with this is we don't have everything taken care of. There's an extra x up there. So we have to solve this for x. So that's going to be u plus 4 is equal to x. And I think if I do all my substitution at this point, I'll bring out the 5. Get rid of that. So my x dx is going to be u plus 4 times du over u cubed. And I'll bring the u up into the numerator, make it u to the negative third, u plus 4 du, and distribute. So that's u to the negative second plus 4u to the negative third du. And now I can take the integrals of each one of these. So that's going to be a 5 times the quantity of u to the negative first over negative 1 plus 4u to the negative second over negative 2. I'll simplify that in a second. Plus c. I'll come over here and finish this as that's going to be a 5 over u to the first, negative, which is x minus 4. And that's going to be a negative, so a negative, that's going to give me a 10x minus 4 squared. And then plus c. Completely simplified. All right, 34, I'm skipping. 35. And again, this part here that's 10, I just simplified that as I went, and I substituted in u at the same time. Okay, this one is going to be a long division problem for number 35. So we're going to have to do, x squared plus 1 into x squared plus x plus 1. Okay, so in x squared plus 1, is going to be a 1, so 1 times x squared is x squared. Just make sure you line up your terms. 1 times 1 is 1. We're going to subtract those. Those are going to simplify out. Those are going to simplify out, so have a remainder of x. So this new function can be written as, time for class to start, we'll keep going. This new function can be written as 1 plus x over x squared plus 1 dx. And now I'm just going to integrate each part. So this is going to be the integral of 1 dx plus the integral of x over x squared plus 1 dx. Excuse me. So the integral of 1 is x, and I'm going to have to use u substitution for this second integral. So u equals x squared plus 1, du equals 2x dx. Bring out the 2, so I'm going to rewrite the integral as 1/2 integrate. The x dx is going to be my du, and this is going to be 1 over u. Alright, so finally, x plus 1/2 ln absolute value of u, which is x squared plus 1, and then plus c. Alright, last couple here. I think we're coming down the home stretch here. Yeah, I guess I'll do this one because I think it gets kind of messy. So u is going to be equal to a negative x squared. Du is equal to negative 2x dx. Bring out the negative 2, so when I rewrite this integral, it's going to be a negative 2, 2 to the u du. And, oops, that's going to be a 1/2, sorry, 1/2. So it's going to be negative 1/2 times the quantity a to the u, so 2 to the negative x squared over the ln of a, which is the ln of 2. And I'll evaluate that from 1 to root 2. And I don't know if it would have been better to switch everything in terms of u, including the upper and lower bounds, and evaluate it, but we're this far, so. Alright, so negative 1/2. 2 raised to the square root of 2 squared is 2, and that's going to be negative 2 over the ln of 2. Minus plug in a 1, so that's 2 to the negative first over the ln of 2. I'm going to simplify inside the parentheses. So I'm going to have a negative 1/2 times 1 over 4 ln of 2 minus 1 over 2 ln of 2. Let's see. Okay, I'll do it this way. Negative 1 over 8 ln of 2 minus plus 1 over 4 ln of 2. And finally, I can simplify the numerator, so it's going to be negative 1 over the ln of 2 to the 8th minus 1 over ln of 2 to the 4th. So that's negative 1 over 2 to the ln of 256 minus 1 over the ln of, what's that, 32? 2 to the 3rd is 8, and that's 16. And I guess we'll stop there. It'd probably be good enough to stop there, but alright. Is that it? Thought there was more. No, that's it. Okay, done. Nice.